Welcome to the virtual tour of the Iowa Department of Public Safety's Division of Criminal Investigation Criminalistics Laboratory. The DCI Criminalistics Laboratory is located on the DMACC campus in Ankeny, next to the Iowa Office of the State Medical Examiner. The DCI Crime Lab is taxpayer-funded and processes evidence free of charge to all law enforcement agencies in the state of Iowa. The DCI Crime Lab has approximately 50 employees, including a lab administrator, criminalist supervisors, criminalist, forensic science technicians, and clerical staff. The DCI Crime Lab is organized into 4 main units, with several different sections in each unit.
This is the evidence room of the DCI Crime Laboratory, and what we do here is receive any evidence that law enforcement agencies in Iowa in general bring to us to be processed by the Crime Lab.
At any given time, the evidence room has approximately 7,000 pieces of evidence. Each year, the evidence room receives approximately 50,000 pieces of evidence for about 16,000 case assignments. In addition, the lab processes thousands of convicted offender DNA samples, firearms, and breath alcohol assignments not included on the forensic assignment counts. The evidence room receives everything from doors, from robberies, to guns and drugs.
We receive evidence in 2 different ways. A lot of evidence is brought here in person by the law enforcement agency. They physically drive it to the laboratory and deliver it here at this counter. The other way we receive evidence is by some sort of carrier, mail carrier. We have kind of the evidence room divided into 2 sides of the house. This is the side where officers bring it and carry in evidence and pick up their evidence. Then the other side of the house is where people in the lab would go to pull evidence out of the evidence room to do their work and then bring it back when they're done. Those items of evidence are inventoried, cataloged, barcoded, entered in a computer database, and the evidence room facilitates those items kind of moving around the laboratory to complete the analytical requests and coming back to the evidence room and then eventually, ultimately back out to the agency that submitted them to us. For any case can be drastically different. We go anywhere from a single item, maybe a drug sample, an item of marijuana, for example, up to maybe even 100 or more items of evidence on a homicide case.
And all of that evidence has to be securely stored.
That vault basically has rows of shelves with unique barcodes on each shelf so that we know where to retrieve a piece of evidence at any given time. We have several different storage options in the evidence vault. The shelving that I mentioned, as well as a walk-in cooler and a walk-in freezer. And the walk-in cooler would store things like blood and urine samples, and the freezer would store some additional different types of biological materials and sometimes some clandestine laboratory materials. From the time a piece of evidence arrives at the crime laboratory, we keep basically a running log or a chain of custody record of every time that piece of evidence moves throughout the laboratory. So from the time it's brought in, by who brought it in from the submitting agency, to the evidence tech who processed it, back to the shelf that it was stored on, out to the analysts in the lab, back to the storage location in the evidence room, and then back out to the submitting agency.
The Firearms and Toolmark section has 4 lab staff that examine firearms and enter ballistics data into state and national databases. The Firearms section boasts a 75-foot shooting range located in the basement of the crime lab and one of the most extensive weapons collections you will likely ever see.
We have somewhere between 4,500 and 5,000 firearms in there. At the last known figures I knew it was roughly over 2,500 handguns and over 1,500 long guns. It is impressive. We have some things that are collector's items that are just too valuable to want to destroy. But most of this stuff is run-of-the-mill stuff. But the vast majority of it has been seized after court adjudication. It does generate a lot of curiosity, but we do use this quite often. Sometimes you'll get a gun in that you haven't seen before, and rather than start to tear it apart without having looked at it, better off to go take a look at the reference one and see, well, this is how it's supposed to go, and this is how it comes apart, and this is how it goes back. And you also want to look and see, has it been modified in any way? It's one of the problems we have now with people trying to do alterations to make semi-automatic weapons fire automatically.
Besides the extensive reference collection, the DCI lab processes all seized guns in the state for destruction.
By state code, every gun that is seized or forfeited to the state of Iowa has to come to the laboratory. We catalog those and keep a database to record what happened to them. For the most part, 90% of them are going to get destroyed. Some of them go into our laboratory's reference collection. We are allowed to keep one of each make, model, and caliber, and we use these as a reference. We may get a gun in that we haven't seen before. Sometimes these guns are broken or they're missing parts, and we have to scavenge parts from our reference collection to make them fireable so that we can obtain test fires, bullets, and cartridge cases. Some of them have value as going back out to different police agencies. They may want to use one for an undercover buy. They may need something for training. Occasionally, from time to time, we have an exchange program with other criminalistics laboratories that we will let them have guns for their reference collection. We happen to have one of the better state reference collections in the United States.
And if the gun collection wasn't cool enough, check out the firing range.
We keep expansive collection of ammunition in here that's used anytime a crime's committed and we have a gun recovered. We try to match the type of ammunition that was used when we're doing our test fires. It only makes sense to compare the same brand and style of bullet or cartridge to the ones that are recovered in the crime scene. We have a steel tank in here that we test fire weapons in. It's full of water, so we recover the cartridge cases, take the bullets out of the water. We also have a steel tube down the range for high-powered rifles. The tank will handle most pistol calibers. And sometimes we get .223 rifles and 7.69 by 3.2, and the biggest rifle I've fired has been a 300 Winchester mag, and our steel tube is full of Kevlar tubing, the same fabric that goes into a police officer's vest, only you can think of it, it's 5 feet of Kevlar. So the bullet ends up, as it's spinning, it gets a big ball of Kevlar around it, and depending on the bullet, it feels anywhere from the size of a golf ball to a tennis ball when we actually physically dig it out by hand and unwrap it, and it'll be a very pristine condition and suitable for comparison. Somebody is in this range test firing a gun every day. On average, we aren't test firing 5 or 6 times a day, so it may not be. I may be doing a lot of test firing. Depends on how many guns we have in a single incident. You know, you may have 1 or 2 cases, so you just have 2 guns to fire. You may have multiple guns. Like every gun we test fire at least 3 bullets and cartridge cases from. When we're doing distance determination down here, we might do 3 test fires in the water tank to recover bullets for that. And then if we're doing a distance determination, we'll probably do a minimum of 5 more shots for that. So that could be 7 or 8 shots per gun. When we've recovered the test fire bullets, we take them back out to our workstations. Each workstation has a zoom stereo microscope, which we use for initial examination. If we have more than 1 bullet submitted, we look at those for grossly to make sure that the lands and grooves line up. They have the same number of lands and groove with the same direction of twist. Once we agree that they have class characteristics, we move them to comparison microscope. That's a specialized tool that we use. It's 2 microscopes that are basically hooked together with an optical bridge. So I can put a test-fired bullet on one side and a bullet from a crime scene on the other, and actually line them up and compare them land to land to see if they were fired in the same gun or if they came from 2 different guns. We do test for the deposition of gunshot residue on articles of clothing or stippling or tattooing on a person, and then we try to replicate that in the lab with test firing onto white cloth witness panels and determine how far the muzzle of the gun was from the victim or the target at the time the shot was fired.
They also enter cartridge casings and specific characteristics of guns into national databases and work with tool marks.
We will look at padlocks that have been cut with bolt cutters. Maybe a door's been pried and there's scratch marks left from the tooth of the pry bar or the screwdriver that was used. And you can even get marks that are left from a knife blade that's used to cut tubing or puncture a tire. We receive clothing. I've received pieces of drywall and pieces of siding that either have bullets embedded in them or a bullet has passed through. We have seen doors and pieces of appliances that either have bullets or have tool marks in them. Clothing, we have sometimes seen pieces of bone that have tool marks where someone's been killed with a stabbing or a hacking instrument.
Likely the most visible part of the DCI Crime Lab to the general public are the DCI crime scene units that are often seen on the news responding to major crimes. The DCI crime scene team is made up of criminalists from the DCI Crime Lab that are on call for a week at a time to respond to major crimes at any given moment, anywhere in the state of Iowa when requested by local, county, state, or federal agencies. The crime scene units are equipped with hundreds of tools used to collect evidence at Iowa's most major crime scenes. The DCI Crime Lab has 2 crime scene units, one larger truck and one 4x4 pickup.
We handle impression evidence, tire tracks, fingerprints, and footwear impressions. We see latent print lifts. We see unprocessed evidence that we then have to process either with super glue or chemical processing to develop latent prints. We also see casts of footwear and tire track impressions, and we also see a variety of digital photos.
All ranging from numerous major crimes.
Sexual assaults, if there's evidence where we need to find some fingerprints, homicides, burglaries, misconduct, vandalism, it really runs the gamut.
To do so, they use some cutting-edge technology.
We use high-powered UV light, most of the time shortwave, and it bounces light off of an object up to a camera which has a barrier filter, and then we're able to look through the image processing software, look at that item of evidence and see fingerprints. And it's really brought up a number of fingerprints we weren't able to see before through other means.
And once they find the fingerprints,
we have both a state system and a federal system that we can look through, and both of those have millions of individual fingerprint cards. What we would do is we would enter either with a photograph or a digital image or a scan, enter a fingerprint into those systems, and it would use computer algorithms to find fingerprints that the computer thinks are the closest matches for the one that we are entering. And then we would go ahead and visually go through each fingerprint and look to see if it was an identification.
The drug identification section has one of the highest volumes of evidence in the DCI Crime Lab and is one of the largest layouts in the crime lab.
Here in the drug identification section, we're looking at actual physical drugs that are coming into the lab, and we are identifying them and submitting a report to our findings. We see a pretty good variety. Our biggest drugs are meth, cocaine, marijuana are definitely our biggest. Heroin is coming back up in popularity lately, and then we see a bunch of synthetic cannabinoids, which are known like K2 or the spice. We see bath salt varieties sometimes. Each analyst is going to have their own little work bay. So we have secure storage for the evidence we're working on at the time, and a hood that we can work in for any, volatile drugs we might be working with. The Clan Lab section is at the far end of the lab, and they kind of have their own area with some larger hoods to work with some of the substances that they work with. We all have a shared instrument room and some shared areas like this that we can do some of the presumptive testing and separation techniques and that kind of thing.
The drug section has a large caseload of evidence to process, and with the hundreds of types of drugs, they have specific tests to help them correctly identify each submission.
If it's a weighable amount, we're going to weigh it and get a net weight, so a weight of just the drug. And then we're going to do any color tests to determine kind of what we're working with. And then from there, we're going to do a presumptive or a separation test. So we're going to either do thin layer chromatography, which is called TLC, or we're going to do a gas chromatograph test, which is our GC for short.
The DNA section of the lab is another large portion of the DCI Crime Lab, and it's split into 2 units, the casework unit and the database unit.
This is where we actually analyze evidence that comes in from criminal cases. These would be cases such as homicides, sexual assaults, burglaries, rapes, murders, any type of criminal case that would be involved. Any type of biological materials that would be left at the scene of crimes that we can use to try and associate a specific individual back to a specific crime.
DNA is very, very sensitive. We can get DNA off of a blood stain the size of a pinhead, or a back of a mailing envelope that has been licked or something. So because of those reasons, the sensitivity and the knowledge that it is out there, we get more and more cases submitted.
The DNA Casework Unit analyzes approximately 150 case assignments a month. The DNA section of the crime lab contains a great deal of technology, which also includes 6 microscopes used by nearly a dozen DNA analysts and forensic science technicians.
This is the actual DNA analysis that's taking place. Once DNA is extracted and quantified, we then must amplify the DNA, and this is the real power of DNA technology today. We can start out with a single copy of our key forensic piece of evidence, say a blood stain at the point of entry in a burglary, and we amplify that DNA that we are looking at, and if we run 30 cycles, we can have between 1 million and 1 billion times more copies of that DNA than we started with. It's almost just like photocopies, the photocopier making copies of that DNA. We can, again, generate enough DNA that we can do an analysis, generate that profile, and either compare it to a known profile that may be submitted in the case if they have a suspect, or that profile then would get entered into the CODIS DNA database and can get searched both at the state level and nationally against all other forensic profiles entered, and also all convicted offenders throughout the entire nation.
The analysts oftentimes receive pieces of clothing or bedding for analysis.
Screening evidence, looking for blood stains, semen stains. So we were in a darkened room where we had what looked almost like a flashlight, and they were actually looking for biological stains on, I believe it was a red or maroon sheet, attempting to identify biological stains that we could run forward or for DNA analysis. So
within the Convicted Offender Database Unit in the DNA section, technicians analyze DNA samples that come from individuals convicted of crimes.
Anyone convicted of a felony, sex crime, or specific aggravated misdemeanors are required to provide a DNA sample to go into our statewide DNA database and then eventually be uploaded to the national DNA database. The workers in here consist of both criminalists and forensic science technicians. Their job is, again, processing these samples. We accession these samples. They come in from all the county jails around the state, all 99 counties, also from the Department of Corrections. Also, Sex Offender Registry submits samples to our laboratories. We get about 10 to 12,000 database samples per year coming in.
Once they take a sampling of DNA, which can be as small as a pinhead.
Once that happens, the data comes off electronically, goes to the computer, and then we will analyze or look at that data and make sure that it has run properly, and then after that the samples get uploaded to a secure CODIS computer where it gets uploaded nationally. We're solving burglaries, sexual assaults, murders throughout Iowa and throughout the United States where we get hits and can solve crime. So it's tremendous, a tremendous tool in the forensic and investigative community for law enforcement to help us solve crimes.
We look for drugs and alcohol in blood and urine. Urine and blood mainly for driving impairment cases, also for drug-facilitated sexual assaults. We also have the oddball cases of someone kills their family and thinks they're under the influence of a drug. We have a screening instrument that all urines that they come in, we will screen them for the presence of drugs. And if we see drugs, positive drugs in our screening instrument, then we'll go on and use more sophisticated instrumentation.
The toxicology section has 2 main areas for processing evidence.
The workbench areas are where people take out sample, open evidence, and they'll process the samples in this lab area. So a lot of the paperwork is done in that. The hood is where we'll handle the biological materials, so the urine or the blood. Our other room is all instrumentation. So this is where we take the extracted drugs out of the urine and we'll analyze it in our instrumentation.
The breath alcohol section is responsible for anything dealing with testing the amount of alcohol off a subject's breath. And there are 3 basic ways the state of Iowa does that. We have evidential breath testing instruments. The current one is the DataMaster DMT. We also have portable breath testing devices and ignition interlock devices.
Once a subject is stopped by law enforcement for suspicion of OWI,
they will check the subject's alcohol level on what's called a PBT, or preliminary or portable breath testing device. And if this alcohol level shows that it's above the per se level, the current per se level, then they'll bring them to the evidential instruments and they'll have them test on this. And this is the result that goes as the evidence in court. These are not admissible in court.
the evidential instrument is called a data master. There's at least one data master in each county in Iowa. Most are housed at the county sheriff's offices.
Our job is to make sure the instrument actually does what it's supposed to. All the safeguards are working properly. It's accurate, precise.
That's why two criminalists spend 5 months out of the year traveling to every county in the state, performing recertification tests on every data master to ensure accuracy.
Photography is the only non-destructive forensic tool that we have available to us. We have to be able to reproduce digitally now, we are now away from film, but digitally we have to reproduce photographs that are within 1/3 of a millimeter to actual life size. We are at the beck and call of anyone within this laboratory that requires physical evidence or anything that has to do with photography. They will request our presence either in different parts of the laboratory, or they will bring physical evidence here into this section. We've had as much as the front end of a pickup truck in here with a bicycle showing fracture matching of an impact from a bicycle seat from a hit and run accident. We've done those types of things. This is just using typical white light type arena. We also do things with ultraviolet. We do things with different wavelengths of light. We try to make things fluoresce. We try to make reflections happen. We try to do all sorts of things to capture something photographically that the human eye may not see.
They also train every criminalist that serves on the DCI crime scene team how to photograph evidence when they respond to the major crime scenes.
You want to approach a scene as if you're telling a story. If you could not say a word in court and all you had were your photographs to show the jury, would it do a storytelling job from beginning to end?
This is that section where any substrate that has marks or symbols that convey thoughts about which questions have been raised in a criminal case, they can end up here. The key function here is to have known material to compare to. So the typical goal is to identify or eliminate a writer or a machine. The most common thing now is threats, or there's a lot of paperwork associated with the drug trade, drug trafficking. So that involves notebooks that are typically written by more than one person, and everything in there is nicknames or symbols and dollar amounts. So the cases vary in time. Some may take me 2 hours, some may take me 4 weeks. I will look through the known writings to see if I have adequate known writings. So I'm comparing cursive to cursive or printing to printing. There are times when all I get is a threat letter and it came out of a notebook. And in those situations, I'm looking for impressions from what may have been written on pieces of paper above the threat. There are also times when it's just a matter of reading what's on a deteriorating document, whether it's covered with blood or other products of decay, and they simply need to know what the document says.
Typically, I will get fire debris, residue from fire scenes. The trace portion, Carl will get, he can get anything from glass, soil, to paint chips, fibers, and explosives. Some cases, people think they've been poisoned, so they'll submit either stomach contents or food, and he tries to analyze it for any kind of poison that might be in there. Looking at the fire debris, we're trying to detect if there's an ignitable liquid present, just by looking at the vapors composed in evidence. And then all of the trace things, he looks at different physical characteristics, and he can use the instruments to tell him more about the elemental compositions. When I get a liquid, we do a burn test, so I'll take a little Q-tip, take a dropper, take some of the liquid, drop it on the Q-tip, and then light it. And if it's a petroleum product, you'll usually get like a black smoky flame, and sometimes alcohol. If you find that, it'll be a blue flame. Same with the explosives. If there's enough sample, he'll take a small amount and light it and see how it reacts or if it burns.